Hey everyone, we're going to take a look at Achieve section 2.2 number 3. We're to on scratch paper, basically they say complete the table that they give you, and guess the value of this limit here. So we're going to do this basically finding this limit numerically, right? And so make sure you're careful of their parenthetical information. That's important for how you enter the final result. You use decimal notation, and then give your answer to one decimal place if needed. So that means if you need to, depending on the table, right, round up to one decimal place in this case. So here's the table, and they give you those values there, and we have to figure out what those are. And so you're plugging into this function, the f of x here that I'm saying is this function here. So we're going to use our calculator to do this one. And I have entered in my y1 there, this function. Make sure you're careful, depending on the model that you have, but if you've got to put that numerator in the parentheses divided by the denominator in parentheses this time, because we're doing subtraction. That needs to be done before we do the division. So we do the numerator, evaluate that first, and then the denominator, evaluate that, and then we divide the two. So this is the expression we're looking at. So I've gone to I've already have it set up, TBL set. If I go second and hit there, I want to make sure that I'm independent variable, I'm in ask mode, dependent variable, I'm in auto mode. So I can plug in the values that I want. Go to table. All right, and you can see right here that I've entered in these values here, 9.002, 9.001, and so on. And then these values are going to be truncated. So sometimes you need more decimal place. So I carry this out to, I guess, 6 decimal places. On a test, I'll typically, on this type of problem, I'll give you the table, but I'll tell you round the values in the table to 5 decimal places or 6 decimal places. So how are you going to do that? Because these are being rounded to 3 decimal places. Well, again, if you use the cursors and highlight that down here, you'll see the unrounded result from the calculator. So now I can round it off to, up to, it looks like 8 or 9, 10 decimal places. So I'm going to round off to 6 decimal places on each of these. So there's 9.002, 9.001, 9.005, and 9.001. Okay. And here, I just rounded off the 7.4. Since the next digit's a 9, I rounded that 4 up to a 5. Doesn't really matter so much as far as the final answer in terms of rounding, but that's what you would want to do if you needed to round to a certain number of decimal places. Highlight that entry. So I also entered in the, these values on the other side. These values are all close to 9, but below 9. These are all close to 9, but above 9. And so as we get closer to 9 from above, 9.002, right, these values are getting closer to 9. What does it look like the function is getting closer and closer to? Well, seems like 13.5. Again, rounding to the nearest decimal place seems to be the most obvious answer here. As we approach 9 from below, right, these values are all less than 9, but getting closer to 9. Also, this is getting closer and closer, I would say, to 13.5, right? And so that would be the estimate for this limit from this numerical analysis, okay? And keep in mind that we can always use numerical analysis to estimate limits, even when we go on further and do limits analytically. So this is a very important skill to be able to do. Hope this helps.